Thank you, students, for watching this study guide video. This study guide is very similar to the actual test you guys will be taking. So let's get started on this. Question number 1, what is the GCF? For those of you confused by that acronym, GCF, that stands for greatest common factor. So what's our greatest common factor of these three terms? We think of something that they all have in common. Well, what's a number that goes into 24 evenly, 20 evenly, and 2 evenly? Well, that would be the number 2. And what else do they all have in common? Well, that would be the letter A. But we think of what's the greatest amount of A's they have in common. And that will just be A to the first power. So our final answer for that one would be 2A. And then a lot of students on number 2, they were confused about what fully factored would mean. Well, that just means in the form of something multiplied by something. So we start with 2A. And then once we factor that out, we have to figure out what we have to multiply by to get back to our original answer. All right. So I'll do this for the first problem just to explain sort of like, I don't know, maybe some of you are more visual learners and maybe helping you guys see that I have to distribute this 2A to each of these terms in here because I have 1, 2, 3 terms. So I need to distribute it 3 times to get back to that original answer. So what would 2A multiplied by something would be equal to 24A cubed? That something would be 12A squared. Let's see, this next thing that I need to distribute to, well, if I multiply 2A times this, I should get 20A squared. Well, that something is, well, positive 10A. And then 2A multiplied by something would get me back to 2A. So that would just be 1. And yeah, that would be your final answer. So when I was helping some students in class, a lot of students recognized that, well, maybe you might be able to try to factor that further, because they recognize that it's a trinomial and it's a quadratic trinomial, meaning that it's in the form of like some number with something squared plus some number with that letter with the to the first power and then a number. But let's just go ahead and try to do that with our split the middle term technique or our X method. The number that goes up top here is this first number multiplied by that last number, so that would be 12. And then we think of that middle number. All right, so now we think of two numbers that multiply to 12 and add up to 10. And you'll notice that there is no certain, or there is no pair of numbers that satisfy this little puzzle. So that's how we know that we couldn't factor that further. So on the test, I won't try to trick you guys like this. If there is something in parentheses, well, most likely, actually, I should say, you definitely would be able to factor it further. Yeah, but for now, this is our final answer since we couldn't find two numbers or we couldn't factor further. All right, questions number 3, 4, 5, we have multiple choice. Starting with number 3, what method would you use to factor the polynomial below? So we have x squared minus 144. Let's try to go through each of these answers and see why they would be either right or wrong. So greatest common factor, if we want to factor using greatest common factor, well, that method tells us that we would first factor out our greatest common factor, sort of like what we did here with finding our 2A and then factoring that out. But if you notice, there's not a greatest common factor with x squared minus 144, right? They both don't have an x. And well, this is technically 1. But yeah, there's no other common factor than 1. So that wouldn't be right. That's wrong. Factor by grouping. Remember, factor by grouping, you need 4 terms. So we only have 2 terms right here, so that's definitely wrong. Let's see, split the middle term. So as I just said with question number 2, in order to apply the split the middle term or the x method, remember we need it in the form of something x squared plus something x plus a space. Or we need a quadratic sort of, I'm blanking, a quadratic, not an equation, quadratic expression, I apologize. We need a quadratic expression. Right now, we just have the x squared, and then we have that number, and we don't necessarily have a x in the middle. So it wouldn't be that one. So I guess process of elimination, if you get to this, of course, that would just be the correct answer. But why is it difference of squares? Well, we recognize that it's literally a difference of squares. This is x squared, and then this is 12 squared. So it's literally a difference of squares. Let me just write that out. X squared minus 12 squared, difference of squares. All right, question number 4. Let's just try to do this one by one as well. So what method would you use to factor the polynomial below? Greatest common factor, we start off with that. Well, all of these are x's, but you notice this last number does not have an x with it as well. So greatest common factor wouldn't be it. Factor by grouping. That would actually work because we have 4 terms. All right, so factor by grouping. Why wouldn't it be split the middle term? As I just said, we need it in the form of this, something x squared plus something x plus a number. And then, of course, it's not a difference of squares because it's not in this sort of setup of something squared minus something squared. All right, and then I don't want to repeat myself, I guess. With number 5, well, we notice that it's in the form of something with x squared minus something x minus 5, or this is a quadratic trinomial. All right, so with quadratic trinomial, we want to split the middle term. That's the answer. All right, with problem number 6, I was helping some students in class and they started using that X method. Unfortunately, remember, we only use the X method or the split the middle term method when we have it in the form of this or pretty much something like this. Right now, we have a lot more complicated sort of situation than that, so we can't use that split the middle term. But we can use the greatest common factor method, sort of what we did for questions number 1 and 2. We identify our greatest common factor. Let's see. What's the number that goes evenly into both, or not both, all of 15, 6, and 9? That number would be 3. And then we look at our letters. What's the greatest amount of x's that they share in common? Well, that would be x to the first power. But we don't need to write that exponent of 1. We just write x. And then what's the greatest amount of y's they have in common? Well, that would just be y to the first power. So 3xy is our greatest common factor. And then just like we did with question number 2, we have to figure out what we want to multiply by to get back to our original question. So let's just take it one step at a time. What do we need to multiply 3 by to get to 15? That would just be 5. X times something would give us x cubed. That's x squared. And then y times something would give us y. So that's just 1. But remember, we don't need to write the multiplication by 1. So let's think of this next term. We have 3 times something gives us 6. That's positive 2. X times something gives us x squared. That's an x. Y times something would give us y squared. That's a y. And then lastly, our last term, 3 times something gives us 9. That's a positive 3. X times something gives us x. We just multiply by 1. But remember, when you're multiplying by 1, you don't need to write that. And then next we have y times something gives us y squared. So that would, or it gives us y cubed. I apologize. So that should be y squared. And yeah, that is your final answer. Notice that some students might try to factor this, But remember, we want it in the terms of something x squared plus something x plus a number. This looks a lot more complicated than that, so that's our final answer right there. All right, question number 7. So remember how I always told you students, always try to factor out your greatest common factor first. Notice that our greatest common factor is just 2. So let's try to do that. We factor out a 2. So once that's outside and then inside, we need to get back to 2x squared minus 50. So in parentheses, we should write x squared minus 25. All right, so now when we get to this point, we have it in terms of something multiplied by something, but now we want to use our difference of squares technique. All right, so using difference of squares, basically, we want to make this, right now we have what is inside parentheses. Remember, to factor something means to put it in terms of multiplication. Right now, this is in terms of something minus something. We want to put it in the form of something multiplied by something. So we can use our difference of squares technique to figure out what goes in those blanks. All right, so just as a reminder, difference of squares. It was the lesson where we had a squared minus b squared is equal to a minus b, a plus b. But I feel like introducing it using a and b was kind of confusing, so I figured I'd try to use colors so that you guys can see the pattern that I'm trying to identify. All right, so basically, we want to get x squared minus 25 into this form. Once we get it into this form, or we rewrite it in this form, we can go ahead and just use this formula right here to get it into that sort of situation in something multiplied by something. So let's go ahead and try to do that. What can we figure out? What would be something that we could square to get to x squared? And that something would be just in x, right? X squared would give us x squared. And then we have to figure out what something would give us 25. So let's go ahead. And that something would be just 5, right? 5 squared gives us 25. All right, running out of room. I should have wrote this on a different paper. But anyways, so now we just go ahead and fill in these boxes with exactly what we found out. So the biggest mistake I'll see some students make is that they also add the exponents. We don't need to add the exponents. We only care about what's inside the boxes. So let's go ahead and set up this, this and this. As our formula says, we have minus, and we also have a plus. And then we literally just fill in the boxes with what we have, because that's our whole motivation for finding that. So in the pink boxes, we write an x. And in the blue boxes, we would write a 5. And then so now we've figured out how to factor that difference of squares, that x squared minus 25. So in this blank and this blank, we literally write this and this. All right, so let's go ahead and do that. Our final answer is x minus 5, x plus 5. All right, so if that process confuses you guys, it's just formulas. I'll provide that formula for you guys on the test. But remember, if we go ahead and multiply this out, we should get back our original equation. So just as an exercise, I will go ahead and show you guys that right now. All right, so first let's go ahead and multiply this out. If you guys remember from double distributive property, we have to multiply this x to this x and this x to that 5. Then we have to, our second distributive property, we have to distribute that negative 5 to that x and that negative 5 to that 5. All right, so let's figure out what that would give us. Let's see. If you guys remember, we should get x squared minus 25. Let's see if it works out. X times x gives us x squared. Negative 5 times x, or sorry, I don't want to go out of order just to not confuse you guys. X times 5 gives us plus 5x. Negative 5 times x is negative 5x. And then negative 5 times 5 is negative 25. All right, and then we're still multiplying by 2, so I'm still going to bring that 2 down. And then now we have to sort of simplify what we have in parentheses. As I said, or as you guys know, we should get x squared minus 25 in parentheses, right? And let's see if we get that. Well, we can combine like terms. Remember, if we have an x right here and an x right here. So if we have 5 of something and we subtract 5 of something, we won't have any of those. So in parentheses, that simplifies to x squared minus 25. And then, of course, we still bring down the 2. And so this should start to look familiar. And then now, remember when we factored out the 2 at the beginning, as you guys know, opposite of factoring is distributing. So we go ahead and distribute that 2 inside, and we should get our original problem. 2 times x squared is 2x squared. 2 times negative 25 is negative 50. And yeah, that's exactly what we started with for number 7. Our original question is 2x squared minus 50. All right, question number 8. We want to fill in the blanks. They actually helped us out with this 2x plus 3 and this 2x plus 3. So basically, if you guys remember from factoring by grouping, our whatever we have in parentheses has to be the same thing. So that's exactly that same setup. So we have to figure out what we need to multiply by. Let's see, 2x plus 3. Factor by grouping, we have to factor something out from this pair. And then if we multiply by 2x plus 3, we should get back to this original equation. So sort of this problem is just thinking about it backwards. I think it's actually easier though, because we already have it set up like this. All right, so what do we need to multiply out here by 2x to get 2x cubed? And that's going to be, well, just x squared. And then a way you can check your answer is if we multiply x squared times 3, that should get that middle term. All right, so what goes in this blank? This would be x squared. And now we repeat the same thing with these two terms. We want to figure out what goes in this blank to get back to this negative 18x minus 27. Well, let's try to check negative 9. Does negative 9 times 2x give us negative 18x? Sure enough. And then does negative 9 times 3 give us negative 27? It definitely does. All right, so fully factored. This is where we write it in the form of something multiplied by something. Fully factored form, we would have 2x plus 3. And then what is left over? X squared minus 9. All right, that's your answer for number 9. All right, number 10, basically the same process as 8 and 9, except with a little less help than just filling the blanks. Now we just do it by ourselves. So we go ahead and group these terms. We know it's going to be factor by grouping because we have 4 terms. So factor by grouping, we have to figure out what they have in common. That would be a 2 and an x. And I want to go ahead and multiply by 5x plus y. All right, negative 15x minus 3y. Hopefully you guys noticed from getting a lot of practice with these problems, most of the time when there's a negative in the middle, you're going to want to factor out a negative number. So we can factor out a negative 3. The reason we do that is because, well, most of the time it'll work out where we have the same thing in parentheses. Because remember, we need the same thing in parentheses to make this work. All right, so negative 3 times, well, 5x would give us negative 15x. And then negative 3 times positive y would give us negative 3y. So yeah, we have it in the same situation, such as like question number 8, where we have something with multiplied by 5x plus y, and then something multiplied by 5xy. So we can go ahead and factor out that 5x plus y. So 5x plus y multiplied by 2x minus 3 is our final answer. All right, question number 11. Okay, so with our x method, remember the number that goes up in question number 11 is this first number multiplied by that last number. So 6 times 6, our final answer for that would be 36. And then with question number 12, our middle number goes there. Remember, we just think about numbers. So the biggest mistake I'm seeing, people are writing negative 13x. That would be incorrect. We just care about the numbers, just negative 13. And then now we have our situation, our little puzzle we want to think of. We want to think of two numbers that multiply to 36, but add up to negative 13. So if some of you can't immediately figure out what those numbers are, well, we can go ahead and make a table with all of our pairs. We can have 1 and 36. After 1, 2. Does 2 go into 36? Yes, 2 goes into 36 18 times. After there would be 3. Does 3 go into 36? Yes, 3 times 12 would give us 36. And then does 4 go into 36? Yes, 4 times 9 gives us 36. And then our last pair, let's see. Actually, let's keep it systematic. Does 5 go into 36? Nope, because our number would have to end in a 5 or a 0. And then what about 6? Yeah, 6 times 6. So yeah, notice that these numbers kept on getting closer and closer to each other. And yeah, now we got 6 times 6, so 36. Okay, so now we check our pairs. Now we want to figure out which of these pairs would multiply to 36, but add up to negative 13. So since they're adding up to negative 13, that tells us that we need both of these two numbers to be negative, because a negative times negative would multiply to a positive 36. All right, so if both of these were negative, that would be negative 37. That doesn't work. This would be negative 20. This would be negative 15. And this would be negative 13. Whoa, that works. Negative 13, that's our puzzle. So negative 4 and negative 9. All right, the main reason we wanted to try to do that is so we can split that middle term. So the biggest mistake I'll see students make is that they only write negative 4 and negative 9 here. The reason that's wrong is because, well, we want to split that middle term. This answer tells me that that middle term is just negative 13. That middle term is negative 13x. So we want negative 4x and negative 9x. And then from here, we factor by grouping. So factor by grouping, let's do it together. 6x squared minus 4x minus 9x plus 6. We group these, we group these. All right, greatest common factor of this. I'm going to do this a little bit more quickly since I went through the first couple examples slowly. It's literally the same thing, but just with different numbers. So we factor out 2x. In parentheses, we have 3x minus 2. From here, remember we see a negative. That could give us a hint that we factor out a negative. And then what do they all have in common? Well, that would just be 3. In parentheses, that'd be 3x minus 2. Does that work? Yeah, it works because we have both of the same thing in parentheses. All right, so our fully factored form, we factor out what they have in common first. So that'd be 3x minus 2. And then what goes in this next parentheses? Well, whatever you're left with. 3x minus 2, and then we're left with 2x minus 3. And that's your final answer. All right, with 15. 15, exactly like the process that we just did, but with different numbers. All right, so let's try to do it together. We make this x method. We notice that we have a quadratic, and we can factor that quadratic using that split the middle term. All right, so what number goes up top here? That'll be this first number and this last number multiplied together. That'll be negative 48. And then this middle number goes right here. All right, so we want to multiply to negative 48 and add up to 2. So we know one of these numbers need to at least be negative. All right, so just because I've got a lot of practice with these problems, I know that our numbers are going to be positive 8 and negative 6. But if you're still having trouble identifying these numbers, please, on the test, go ahead and write all your guys' combinations of whatever would multiply to 48, and it's a lot easier to think of it. All right, so now we have our two numbers. Now that allows us to split up our middle term. So we're only splitting this. The rest of it we just write as is. So we literally rewrite 3x squared plus 8x. We get the 8 from there. Minus 6x minus 16. All right, and then we factor by grouping. So out of 3x squared plus 8x, we notice that they only share a x. In parentheses, we have 3x plus 8. Then we see that we have a negative, so we should go ahead and remember that we need to factor out a negative. All right, so our greatest common factor of this would be negative 2. And then in parentheses, hopefully it matches with 3x plus 8. So negative 2 times 3x, yep. And then plus 8. Yeah, that definitely works because negative 2 times a positive 8 gives us negative 16. All right, and then same thing as we did before, right? Fully factored form, we factor out the 3x plus 8. And then what are we left with? X minus 2. Final answer. All right, question number 16. We want to factor the polynomial below. So notice that we have it in the form of a quadratic trinomial. So we go ahead and use our x method. We want to find two numbers that multiply to, well, this looks a little weird. We don't necessarily have a number in front. Remember that number is technically 1. So this first number multiplied by that last number, that'll give us negative 72. And that middle number goes down there. So we want to figure out two numbers that multiply to negative 72 and add up to negative 6. All right. So if I did maybe this process that I went up here, I would be able to realize that, well, my two numbers would be, let's see, 12 and 6. Sorry about that. 12 times 6. That gives us a positive 72. So we want one of those to be negative. But which one needs to be negative? Well, it depends on what number we have here. So we want to add up to negative 6. So we notice that our negative 12 should be right there. All right, so remember, students, if you want to use the shortcut method, you absolutely could on this one because we don't have a number in front of x squared, or that number is technically just a 1. So in fully factored form, our shortcut method, we go ahead and create that sort of setup. And then remember, we put an X right here and an X right here. And what goes in the blanks, that's literally whatever numbers you have over here. So negative 12, so minus 12, and then plus 6. Yeah, nice little shortcut method. A lot easier to make less mistakes. But once again, please remember, you can only use that shortcut method if the coefficient or the number in front of x squared is just 1 or there is no number. All right, nice. I see that we can use the shortcut method for this trinomial or this quadratic trinomial because I don't have a number in front of it. So that's always nice to use shortcuts. Let's try to figure out what number goes in 17. Well, we want to figure out 1 because that's technically 1. 1 times 63, so that's 63. And then that middle number goes down at the bottom. That'll be 16. Two numbers that multiply to 63 add up to 16. Those two numbers would be 9 and 7. Fully factored form. Remember, shortcut method, since there's no number in front, we can go ahead and write it in this situation or that setup. Always going to be an X there, always going to be an X there. And then we go ahead and write each of those numbers in there. This is a 9, so we write plus 9. This is a positive 7, so we write plus 7. That is your final answer. Maybe some of you are wondering, why do we always have to have an X there? Well, let's try to answer that by multiplying this out. Remember, if we double distribute this, we would multiply X times X, and we would get X squared. So the only way we could have no number with the X squared is if we just have an X multiplied by an X. All right, question number 20. As you guys can see, this would be a difference of squares. But how do I know that it's going to be a difference of squares? Well, we can look at both of these numbers. Remember, we always try to factor out a greatest common factor. And I mean, this might look like there's a greatest common factor, but there isn't. The only common factor is 1. But remember, we don't need to write that 1. But how do I recognize that it's a difference of squares? Well, most of the time, I actually should say all the time, when you have a difference of squares, it's only going to be 2 terms. And then you're going to have a subtraction sign in the middle. So a difference of squares. And then, yeah, so basically we want to figure out what goes in these boxes, right? Once again, we want to figure out how we can rewrite this equation as something squared minus something squared. All right, so let's just take it one step at a time. With the pink box, we want to figure out what we need to multiply by itself or what we need to square to get 36x squared. So let's just think of this step by step. So what number could I square to get to 36? That number would be 6. 6 times 6 is 36. And then what do I need to square to get to x squared? That would just be 6x. Right? If you guys are forgetting, maybe this is confusing you guys. Literally, to square something means to multiply it by itself. Let's try to write that out. So if I want to square 6x, that would be 6x multiplied by 6x. You guys got a lot of practice with this last chapter. 6 times 6, that'll be 36. And x times x, that'll be x squared. So yeah, we're not changing the problem. We're just changing how we write it so that we could put it into this factored form. All right, what goes in the blue box? Well, same line of thinking. We want to figure out something multiplied by something or something squared is going to give us 49y squared. And that something would be 7y. All right, and as I said before, well, we get it into this format so that now we can just use our formula to rewrite it in factored form. Fully factored, or our factored form is something multiplied by something. And then let's literally rewrite it in this process. Our pink boxes are going to be filled in with 6x and 6x. So that goes there. 6x, 6x. All right. And then there is a minus sign and a plus sign. So don't forget that. Minus and plus sign. Doesn't matter which way you write it. If you write this one as a plus, you have to have this one as a minus. So you have to have one of each. And then next we have 7y. So 7y goes there, and then 7y goes there. And then that's our final answer. 6x minus 7y multiplied by 6x plus 7y. All right. So if we multiply that out, we get back to our original question. If you guys don't believe me, go ahead and try to do it by your guys selves. All right, question number 21. This one, a lot of students had trouble with this. So let's try to do this. Remember, students, I always tell you guys to factor out our greatest common factor first. So our greatest common factor would be 2. So factoring out that 2, we get 2 multiplied by 4x squared minus x minus 5. All right, so once we factor out that 2, you guys will notice that we still have a trinomial or a quadratic trinomial. So what we need to do now is try to factor this. Remember if we factor this, we literally write it in the terms of something multiplied by something. And then we still need that 2, so let's bring down that 2 as well. And then how can we factor this trinomial? Well, exactly as you would do if you like this trinomial right here with that x method. So let's see, I don't have room down there. Let's try to do it. I'll just do it on another piece of paper. All right, so right now, let's ignore the 2 for now. We are just trying to work with this, the 4x squared minus x minus 5. So let's just go ahead and rewrite that, 4x squared minus x minus 5. And as I said, we want to get it into factored form. So since we're just ignoring that 2 for now, we only care about this. How do we factor this? Well, we use that split the middle term or that x method. Up top is negative 20. Down here is negative 1. Two numbers that multiply to negative 20 add up to negative 1. That's going to be negative 5 and positive 4. All right, so splitting the middle term, we write 4x squared minus 5x plus 4x minus 5. All right, greatest common factor of these first 2 terms is going to be x. And in parentheses, we write 4x minus 5. Our greatest common factor of 4x minus 5, that'll be just 1. So plus 1, and then in parentheses, 4x minus 5. All right, so in parentheses, we have the same thing. So now we write it in factored form. We write x plus 1, 4x minus 5. So yeah, that's our answer for that. But that's not our final answer. Remember, let's go back to that other problem. We don't forget about that 2, but we figured out what we can rewrite 4x squared minus x minus 5 as, with something multiplied by something. And that would be x plus 1 multiplied by 4x minus 5. So let's go ahead and put that in parentheses. X plus 1, 4x minus 5. And there we go. That is our final answer. So please, students, the biggest mistake I noticed when I was helping students with their study guides is that they would factor this and then they would forget about the 2 that they factored out, and their final answer was just this. Remember, our final answer, when we multiply it out, we should get back to our original problem. If we only multiply this together, we only get this, but we want this. Another mistake I noticed some students making is they don't factor out the greatest common factor first. So they didn't factor out a 2. I won't take too much points off, but I don't want you guys losing easy points. So remember, I told you guys always factor out a greatest common factor first. All right, question number 2. We have 4 terms. So we want to go ahead and factor this by grouping. So let's go ahead and group this. And we group this. All right, greatest common factor of this would be 4x squared. In parentheses, let's see, 4x squared times x, I believe, yeah, x would give us 4x cubed. 4x squared times, what would that be, 5? Yeah, just a 5 plus 5 would give us 20x squared. Once again, we have that minus sign in the middle, so let's go ahead and try to factor out a negative 9. And then in parentheses, well, negative 9 times x would give me negative 9x. Negative 9 times positive 5 would give me negative 45. And then, yeah, so it works out. We have this x minus 5 in parentheses and this x minus 5 in parentheses. All right, so final answer, we go ahead and write x plus 5, 4x squared minus 9. That is your final answer.